Now let's give attention to a certain kind of equation that looks different from the other ones that we've been working with. So circles are ones that have both x and y squared. In general, they consist of all points x comma y that are a fixed distance away from a certain given point. So, some vocabulary about this to remind you of. That certain point that they are a fixed distance away from is called the center. And in general, if we have the graph of a circle like this, the center will just be right here. And this could be located anywhere, so I'm just going to call this h comma k. It's normally the letters that we use to talk about the center of a circle. Now, all the points that are the same distance away from that center point, they form this shape, a circle, of course. Everything on the circle is the same distance away. Now, that distance could be whatever we would like. So this we need to call something too. So that fixed distance is, of course, called the radius of the circle. So the radius, if we were to sketch it in this picture, will be from the center out to any point on the circle. So this will be the radius, and we'll use little r to denote that. Okay, and then again, any point that is on the circle here, any point that lies on the circle that is the distance r from that center point would just be a solution to the equation that we'll write down an algebraic formula for a point x comma y. And we do have what is called the standard form of an equation for a circle. So what that looks like is parentheses x minus h whole thing squared plus parentheses y minus k whole thing squared is equal to r squared. Now, if you're wondering where this comes from, because it looks pretty complicated, it is actually, again, just the Pythagorean theorem. So let's break this down and I'll just explain to you why that this is what it is. So if you think about drawing a triangle based on the points that are on the circle. So let's just use the one that we've got here in pink. So we know that this length here is r, and if we draw a right triangle, then that r becomes the hypotenuse of the right triangle. We do need to figure out, though, if we want to relate, this x comma y coordinate and these other lengths here, we need to figure out what these lengths are. So let's do the horizontal length first. So this length here, well, if I'm calling this point x comma y, then I know it looks kind of weird, but we've gone out to an x coordinate of x. Okay, this point here is just the x coordinate of the center. So that point right there at the other side of the leg is h. So the length from here to here is going to be x minus h, or the upper number minus the lower number. Okay, so this is going to be x minus h is that length or that distance. We can do the same thing for the vertical length here, or the length of the other leg. So we want to find this distance. On the y-axis, the height there is the y-coordinate of the center. So this is k. Then the y value here is I don't know, we're just using this point as an example, is just y is what we're calling it. So let's label that as just y. Then the length here or here is just the difference between k and y. So we're squaring, so we could put that as k minus y. And we can also put it as y minus k. Oops. It doesn't matter. It's actually the absolute value. So I'm going to put it as k minus y because in this context it makes the most sense. But when we end up squaring, like we do in the formula, if this is positive or negative, you'll get the same thing when you square it. Okay, so in the Pythagorean theorem, what we will get is x minus h whole thing squared, right? Just this length, k minus y whole thing squared. And then the hypotenuse was r, so that's equal to r squared. Now again, this doesn't look like what I have down here in this gray box, but if you square the difference of two things, then we can just swap their order and you'll get the same thing. So let's find an equation of the circle where 0, 0 and 6, 8, those two coordinates, lie on the diameter of the circle. I would start by plotting these points and drawing a picture. So let's see, we've got only some positive coordinates here, so I'm just going to use the first quadrant. Let's label, we've got 0, 0, so I can just plot that. Then we've got 6, 8, so I don't know, maybe we'll go out to like 10 on each axis. Oh, I only made it to 8 there. That's okay. Here's 6. I do need to go up to 8 on the y-axis. Okay, that's fine. So our other point here, 6, 8, is going to be right here. Now, if these 2 points lie on the diameter of the circle, well, that's just points that lie on the circle that are opposite each other. So if we were going to graph this circle or draw the picture of it, it might look something like this. It's a kind of wobbly circle, but there's a general shape. All right, now in order to find the equation of the circle, remember what we're looking for is x minus h squared plus y minus k squared equals r squared. And what we need is the h and the k from the center, and then we need the radius. Those will just be numbers that we're going to put into our equation. X and y will stay as x and y, but once we find h, k, and r, then we'll have our equation of the circle. So in order to find the center, well, we have 2 points on the diameter. The diameter will always go through the center, and the midpoint of the diameter is going to be exactly in the center. So if we find the midpoint between 0, 0 and 6, 8, that's going to be where the center is located. So let's go ahead and do that first. So we're going to find the midpoint between 0, 0 and 6, 8. So remember this midpoint formula is we average the x values and we average the y values. So it's x1 plus x2 over 2, comma, y1 plus y2 over 2. Now if we average the x's, we will get 6 plus 0 over 2. And if we average the y's, we will get 8 plus 0 over 2. 6 plus 0 is 6. 6 over 2 is 3. 8 plus 0 is 8. And 8 over 2 is 4. So there's our center coordinate. So let's write, does that make sense with our picture? 1, 2, 3, 1, 2, 3, 4. Okay, not exact, but my graph is kind of wonky. So yeah, so let's say our center here is 3, 4. So in other words, this is h and that's k. So we found these two things. Now we just need to find the radius. Well, we know the 2 points on the diameter. Well, if we cut that length in half from here to here, that will be the radius. So 2 ways you could go about this is just finding the distance from the 2 points on the diameter and cutting that in half, or finding the distance between one of the points and the center, either 0, 0 and the center, or the center and 6, 8. I like the idea of using the center and the point 0, 0. So I'm just going to do that. So let's find the radius. It's going to be the distance between 0, 0 and the center of 3, 4. You could use the distance formula, but if you just take a look at this here, it's conveniently located at 0, 0. So let's just use the Pythagorean theorem because we have a nice right triangle here already. The one leg here is 3 and the other leg here is 4. So using the Pythagorean theorem, we will have that r squared equals 3 squared plus 4 squared. 3 squared is 9 and 4 squared is 16. And when you add those, you get 25. If we solve for r, we'll take the square root. We would really get plus and minus 5, but r is a length, and so we just want to take the positive number for that. Okay, so there we have found all of the pieces. So let's just write it in standard form. So it's x minus h, which was 3 squared, plus y minus k, which was 4 squared, and then equals 5 squared. Or in other words, we could put 25 there on the right-hand side, just make that look a little bit better.